שמעון, אתה מציג.
אוקיי.
שמעון?
1 minute, we'll start exactly on time, and we will start. Okay, hi everyone. Thank you for joining RADWIN webinars. RADWIN, this course is about RADWIN radio planning. The major tool for planning and design links. It can be point-to-point or point-to-multipoint. My name is Shimon Mishal. I'm the Professional Services Director for Europe and Africa. With me, Mr. Eldad is of the team, Professional Services. Eldad will help and assist to answer your question in parallel to the webinar. And of course, if there is other questions, I will answer those questions at the end of the webinar. The idea, the webinar should take 1 hour, and tomorrow and after tomorrow, we have additional webinars which are complementary to this introduction RADWIN planner tool. Now, the RADWIN planner tool is the major tool for planning and design links. It's based, before I will start with the presentation, I will show you the RADWIN link budget calculator. Actually, the R planner is based on link budget calculator. So I will go to the web interface and show you the link budget calculator. This is the RADWIN link budget calculator. By the way, it is you can take the link. It's a web access. It's free, and everyone can practice this link budget calculator. On the screen, you see a link budget calculator for RADWIN 2000 point-to-point and for RADWIN 5000 point-to-multipoint. Later on the next course tomorrow, we are going to design and plan point-to-point and point-to-multipoint, and I will explain what is the difference, the major difference between point-to-point and point-to-multipoint. Actually, they are all based on RADWIN platforms, and when you are planning a link, it doesn't matter if it is a point-to-point or point-to-multipoint. There are benchmarks which need to be considered in order to design a proper link. For example, fade margin. What is the fade margin that we plan, and the benchmark for fade margin when we're planning a point-to-point or point-to-multipoint link? Usually, fade margin can be between 10 to 20 dBm. It depends on the how much you intend to invest on the link. And usually when we're planning a link, I always say to my students that a proper link efficient link save money. And we are all here to make money. But from the other hand, we need to save money. And if you are doing a proper planning, you are saving money. So we discussed about benchmark, fade margin. What is the fade margin that we are planning to our link? It depends on what is the condition that we expect. Is it above water? If there is lakes or mountains near line of sight, no line of sight. What is the availability that we are planning? What is the RSS? What is the signal that we expect vs distance? What are the modulation? What is the TX power? What is the climate factor? What is the climate factor that we expect in different areas or different condition or humidity? What is the antenna gain? At the end, the bottom line, we are expecting to see what is the throughput. But throughput is only the outcome of our planning and how properly we did the planning. So what you see on the screen is the point-to-point link budget calculator and the point-to-multi-point link budget calculator. Now, in the link budget calculator for point-to-multi-point, there is a question mark at the bottom. And when I press this button, you can see that there is a table that shows you what is the resources that you need to allocate for each point-to-multi-point link on the uplink and the downlink. And this is the major difference between point-to-point and point-to-multi. What is the quality? What is the main difference between point-to-point and point-to-multi-point? What is 1% of resources in terms of capacity? So when we are doing the calculation for point-to-multi-point, you need to understand that point-to-multi-point requires resources on the uplink and the downlink according to the benchmarks that you are planning: fade margin, availability, RSS, TX power, modulation, the distance, the antenna gain that you are planning for a specific link. Point-to-multi-point became more complicated because every subscriber is an entity that we need to adapt the planning for each subscriber. So the link budget calculator and the R planner that we are starting to discuss now are based on the same algorithm. We are taking a planning, we need to consider the benchmark for fade margin, for availability. For example, fade margin, I expect above 10 or 20, depend on the policy of the carrier or depend on the policy of the WISP that is deploying the link. So fade margin is between 10 and 20 dB. What about availability? Availability, I can plan a link based on 999 or 49 or 59. But remember, the more you are asking for a strict demand of the designed link, you need to invest more and more facilities in order to guarantee the availability. What is the RSS? So when I do the planning, I take the benchmark. For example, fade margin is between 10 and 20. Availability, 49. RSS is the strength of the signal in distance. I prefer that the RSS will be between minus 45 dBm to minus 65 dBm. And of course, I want to guarantee that the modulation will be the higher modulation to get better throughput. The more you have symbols over there, you get more throughput. And climate factor. I always take consideration what is the climate factor for each region to guarantee the performance of the link in a harsh condition. So we are looking on performance from one hand, and we want to guarantee and ensure the performance of the link in different air conditions when there is interference, when there is an obstacle like near line of sight or non-line of sight. So introduction to this R planner, the RADWIN R planner, radio planning, is based on link budget calculator. The link budget calculator is a web access GUI, and you can practice the web GUI according to the benchmark that I gave you before: phase margin, availability, RSS, TX power, modulation, distance, climate factor, antenna gain, and the output is the throughput that you will get according to the benchmark that you are planning. So let me start to introduce to you the R planner. Maybe I'm starting from the last, but let's look. This is the RADWIN R planner. And usually, if it is a frontal lecture, I will ask the student, what do you see? What do you see? And I'm answering. We have here a 4 sector of point to multi-point. You see the red color and the blue color. When we are considering and we're doing the planning, we need to consider the spectrum that we have. What is the channel bandwidth? What is the frequency? What is the regulation that we are using? Some countries in Europe use the majority of the countries in Europe use the ETSI, the European standard. Some countries in Africa or even in Europe doesn't consider the limitation of the EIRP and the limitation of TX power. So they are using the universal frequencies and the universal band. In this R planner, you can see that there are 4 sectors. The blue are F1, the red is F2. Actually, because of beamforming antenna on the point to multi-point, we can afford ourselves to do a planning based on 2 frequencies. F1, which is the blue color, F2 is the red color. So actually, I have here 4 coverage of 4 sectors, the blue and the red. When the blue color is F2 and the F1, the blue color, and F2 is the red color. Now, the narrow green lines are the point to multi-point links. When the wide lines are the point to point. So there is a mixture of point to multi-point and point to point here, here, and here. Now, if I may ask you why I considered a mixture of both point to point and point to multi. So actually, the answer is clear. And the radio planning gives us a lot of information where we need to consider. And in this course, I will give you all the information how to do a proper planning. Why I did here a point to point and point to multi-point mixture in one planning? The answer is clear. Because of topological limitation, near line of sight, non-line of sight. Here, for example, the topological not allow us or give us the opportunity to do full point-to-point. That's why I did a point-to-point complementary to the point-to-multipoint. Let's see. If I look at the profile, when I did a backup of a subscriber or a customer to a subscriber unit, which is a point-to-multipoint, I can overcome or bypass topological obstacle. Here, you can see here the same. If I do the profile, you can see here that still there is a topological obstacle, which I may or not consider to do with the point-to-multipoint and not with a point-to-point connection. So profile of the link, the Fresnel zone is one of the considerations that we need to take when we are doing a plan. Now, if you're looking at again at the picture and the R planner, it's a planning of point-to-point and point-to-multipoint. When there are 4 different base stations which are covered 360 degrees. The radio planning gives us the link budget calculator for every link, and you can see it on the property. I can see the distance, I can see the phase margin, I can see again the RSS, the availability, the modulation that I expect, and of course the throughput that I can expect. At the end of this course, on the last module, I expect that you will be able to understand what you are seeing on the properties, to read, to be able to do the planning and to understand what are the performance that expected when you are doing the planning. So this is the R planner, and this is how we do a mixture of point-to-point and point-to-multipoint on one planning. Let me open the slide and let's start with the course. The agenda of this course, chapter 1 is solution highlights, chapter 2 installation architecture, chapter 3 building the topology. The R planner is one of RADWIN cloud services, what we call OSS, operating support services. Now, the R planner is one of them. Actually, it's a planning tool where you can design a link. A link can be a point-to-point or point-to-multipoint. In the future, we will be able to do planning for TV white space and for a microwave solution, which are coming very soon this year as a complementary to our portfolio. The TV white space for non-line of sight solutions, vegetation, and for a telegraph 60 gig solution to provide higher capacity for for cities, towns, and neighborhoods. So the radio planning has all these capabilities, but we have also the service estimation tool. It's all on the cloud. It's a free service that everyone can use and enjoy the benefits of a good design of link, a good ability to provide service estimation to future links or future subscriber that's asking to be registered to existing deployment. The service estimation tool gives you the ability to estimate a service for a new customer. and a secretary sitting behind the desk have the information of real deployment that we already did. She just needs to type the address or the coordinates of a new subscriber, and immediately she will get the information about a new service. And the performance of a link or a new subscriber, in case we are going to install it or deploy it in the same area where a base station already exists. The customer deployment planning and management, we call it DM, it's called development manager, give us the tool to monitor, control massive of deployment. What has been done, what is the future installation deployment plan, and it gives the companies to control and track their system integrator while they are doing the installation and deployment. According to work orders. So if I do generate a work order to my system integrator, I can track his efficiency, how much he did in a day, in a week, or a month. I can track and follow and monitor our installer. And we have the WinTouch. The WinTouch is a platform based on a cellular application where you can create a work order to your installer. The work order comes with the cellular application to the side and start to align the antenna. Alignment of antenna become much easier, much simple, where you can the installer can get a very good accurate alignment of the antenna, and the decision is done and made by the application. The installer just needs to follow the instruction, and definitely it will get a very good performance if he will just follow the instruction, how to align the antenna. It's called the WinTouch, and everyone can download this application from the App Store. It can be installed on an Android cellular phone or iPhone. It's called WinTouch, and the application helps to create a work order or a project to installer. The installer comes to the site, connect with the cellular phone to the subscriber unit by the Wi-Fi, and immediately will get the instruction how to align the antenna in order to get the best RSS level. So the installer just needs to follow the instruction. The latest tool is called the WinManage. The WinManage, and the WinManage is a NMS to monitor, troubleshoot, get the report for every element in the system. This is the RADWIN NMS. It's a Linux based, Ubuntu based. Actually, it will provide you real-time information and statistics, fault management, performance monitoring, reporting, and of course, user management. So this is the cloud services. The RADWIN R Planner is one of them. Okay, the RADWIN R Planner, radio network planning, radio network planning for best coverage and capacity, for point-to-point or point-to-multipoint. It provides you coverage planning, frequency planning, network sizing, and reporting and analytics. Coverage planning, it will provide you a line of sight according to the topography. You can see the profile of the link. And if you can see the dark areas of the coverage, you can see a non-line of sight site where there is no ability to create a link, a proper link, because of the dark areas. Dark areas mean that you will get, and you can expect probably a non-line of sight. Additionally, you can distinguish between colors on the coverage. Dark color means that the modulation are higher modulation. And of course, if you go far away in the distance, you can expect less or deterioration in the modulation. So the dark coverage means better modulation. So as much as you go far away from the base station, or the link become more distance, you can expect deterioration of the modulation, and of course it will impact the throughput that you expect to get. Black areas are non-line of sight area according to topography. Check line of sight according to topography and plan the best location of your base station and your subscriber for optimized coverage of your customer. And as I showed you in my planning, you can see that I bypassed a topological obstacle by doing a mixture of point-to-point and point-to-multipoint. This is the main challenge in point-to-multipoint. When you are having one central base station and you expect to cover a large area, this is the main challenge, because we can expect vegetation, we can expect buildings to maybe to block and to perform a shadow on the signal that we are transmitting. So near line of sight, non-line of sight are need to be considered when we are doing the planning. And of course, we need to choose and plan the best location of the base station. Frequency planning. Automatically assign frequency according to channel bandwidth. Select frequency per sector. Again, when we are doing the planning, choosing the spectrum, the availability of spectrum, this is very important. And the radio planning is doing for us the frequency assignment, and it tests the availability of the spectrum according to the planning that we did. The outcome of the radio planning is a BOM, a bill of material, where it gives you the exact quantities for each deployment or each planning. It's based on RADWIN products. And when you are creating the planning, at the end, you need to generate the BOM, the bill of material document. Create your BOM according to your planning. See how many units you need. Plan your budget accordingly. If I go back to my, I will go back to the screen to show you my my planning. This is the planning that I did. Remember, 4 sector subscriber units for point-to-point and a point-to-multipoint that bypass topological areas which they are dark, which indicate non-line of sight. If I go to this button, there is a report button. You can generate a report, you can generate a KMZ file, based on Google Map and generate a bomb. When you are generating the bomb, it asks you whether you are asking to generate a bomb based on the material that you, on the equipment you choose in the map. I press no, and I get the bill of material that I did during the planning. I can see that I have 11 subscriber of point to multi-point subscriber units, 4 base station, 4 jet beamforming base station, and 6 point-to point links. Remember the point-to-point that we need to bypass the topological area. And of course, when I do the planning, and tomorrow we probably discuss it, we need to take into consideration and consider synchronization. How properly to synchronize the entire network. So this is something that we need to consider. And I'm not going to do it now, but I will do it definitely later. You can see here on the third button, there is a map parameters and radio layers. One of the radio layers is the synchronization, how to properly synchronize a link. And later on, I will discuss about synchronization. Currently, there are reports. The reports are the radio planning itself, the KMZ file, and the bomb. So the bomb, the bill of material, you can plan your budget accordingly and plan a specific bomb or bill of material for a specific site. What are the subscriber units? How many subscriber units you need to provide? What is the DC power, the AC power, the cable length, lightning protectors, grounding system, everything that is related to the installation and deployment of a specific site. So at the end, when you are generating the report, you can add the bill of material, and this is something that you need to provide to your installer. What is the bill of material per site? What is the radio planning per site? What is the azimuth of the antenna? What is the tilt of the antenna? What is the RSS that he expects to get when he is doing the planning? So the report, the radio planning, and the bill of materials are very important in order to go to the site and do the deployment of the installation. So when you press on generate a bomb, it will generate a bill of material and will give you the exact quantity of the planning. Analytics. You can analyze your plan according to many parameters. Generate a report that summarizes your plan. You can do analytics according to equipment, to throughput, on the uplink, on the downlink, analytic on RSS, and so on. And at the end, you will get a full report on the planning that you did to summarize your plan. It's simple. You just generate a report and you get full analytics and statistics about your planning that you did. But actually, when you are pricing the report, you will get all this information in one Word document that explains all this information in one imported document for radio planning. So usually when I do the planning, I create the KMZ file, I create the Word radio planning document, and I provide the BOM, the bill of material that describe the quantities and the exact product that I need to deploy. So this is the analytic report. And actually, this is the output that I can get from a planning. Now, when you are doing the planning, before you are doing the planning, you need to be certified with RADWIN equipment, to be certified with RADWIN radio planning platform. And when I get, it's a very short training for radio planning. You are certified. You will be able to connect and download the RADWIN planner tool. When you are downloading the radio planning tool, you can start work with the tool. You need to be certified. You need to have the credential to work with the tool. Now, when you have the credentials for the tool, you are the only one who can have the ability to see what you are doing. Because you have the credential, you have the planning, and you did the planning, nobody can get and understand what you are doing unless you are sharing those planning with others. So the credentials are important. You need to be certified and registered to the RADWIN portal in order to get the installation link. So the R Planner is a RADWIN online RF tool. The server is located in RADWIN, and we are maintaining the server to all our customers. But every customer has unique credential for his own planning, and nobody can get, it's a secured server, and no one else but the specific customer can see, and unless he will share the planning with the others. So the RADWIN R Planner is an enhanced RF planning tool available to all users. Once you get the credential, you register to the portal, you did the training, you will be able to start working. Intuitive and easy to use, fast self-learning curve, free updates. From time to time, we're adding a new feature like auto connect, which allow you auto connection of thousands of subscribers to base station. You don't need to decide by yourself which base station to connect to which subscriber. The planning will do it for you. Automatic, easy to edit bomb generation, comprehensive planning report, easy share with peers and remote user, full access to RADWIN complete product portfolio. And this is very important. The radio planning takes all RADWIN portfolio, antenna gain, specification of the antenna, the technical specification of each line of product, and take it into consideration when you're doing the planning. The link battery calculator is based on the transmit fixed power, on the antenna gain, the C2I, the sensitivity of each transmitter. So when you are doing the planning, remember it's based on RADWIN product and the technical specification of each individual product. The server is located in RADWIN, and when you are download the radio planning software, you can install it on your computer, and the output of the radio planning when you complete the planning is bill of material, document, report generator, and a PRJ file which you can export and import a planning file, and you can send it to your manager, send it to your colleague, or even to the installer that is doing the installation. So the outputs are BOM, radio plan, document, and the PRJ file, which you can import and export. When you cannot open a file, PRJ file, without the R Planner. And remember, you need to be online, always to be online with the server through the internet connection. So when you are doing the planning, the internet connection needs to be stable and fast and steady, because you need to be online. You cannot open a PLG file if you are not online connected to the server, to the cloud. And remember, the App Planner is one of RADWIN cloud services. It's a cloud services, and we provide it free to our customer to be able to do their own planning. From time to time, if you have any question when you are doing a planning, the PS team, the professional service team, is available to answer any question on planning and to help you and assist you to do a proper planning. And remember my slogan, and I will repeat my slogan: proper planning save money. When you get the credential, RADWIN will send you a link to the RADWIN, to the planner. You will be able to access to the RADWIN portal and to download the App Planner to your laptop. Very simple. You just need to follow the instruction, and you will get the icon of the App Planner to your laptop. So if I'm looking at the screen, this is the RADWIN App Planner icon. When you do the installation and finish the installation, you will be able to see the App Planner icon on your desktop. Okay. That's your application shortcut. Double-click the App Planner icon. A new dialog will show up on your screen. Type your username and password and get ready to go. So actually, when you get the credential, you will be able to start and doing a planning. As I showed you at the very start and the beginning of this course, and I always want you to remember that the App Planner is based first on RADWIN product, has all the capabilities, all the technical specification of each unit or each device or each ODU, the C2I, the sensitivity, the modulation, the TX power, the antenna gain. And remember, when we are doing the planning, it's based on link budget calculation. The same as I showed you at the very start. And we need to take into consideration and to decide which are the benchmark that we are going to do and deploy our link. What is the availability? 999, 49, or 59? What is the fade margin? What is the RSS? What is the modulation that I expect, and so on. So the App Planner is doing the link budget calculator, the service calculation, the BOM generation, and the report generation. So first we need to install it on our laptop. When you're online, if there is a software upgrade, it will ask you to do the software upgrade, and then you will be able to do the project planning. So the benefit of the App Planner is clear. It's a user architectural SRTM database and frequency assigned. If there is a firewall, you need to open the firewall to HTTP to TCP port 80 in order to allow the App Planner to work. And of course, it's based on Google Earth plugin. And you need to do the instruction when you are doing the installation. Now, running App Planner architecture is based on a project plan required using a product library catalog. A project plan required using a product library catalog. The catalog includes all devices needed for a plan, antenna. The catalog includes all devices needed for a plan, antennas, radios, PoE, IDUs, cable, etc. The catalog can be shared with others. So when we are creating a plan, we need to create a catalog. The first thing that we need to do is to create a catalog of products. It can be point-to-point or point-to-multi. So before I continue to the next slide, this is the RADWIN catalog. It's called WinPro. The WinPro has all RADWIN equipment, and you can filter equipment according to point-to-point, the RADWIN 2000 family, the point-to-multi-point, the 5000 family, and the jet beamforming platform, which can be a jet 4 or jet air, and I will discuss it later, and the jet dual carrier, which can provide 5.x and 3.x, or the 5 and 5 jet duo, the new jet duo platform that we have recently. So actually you can go from left to right and filter the proper or the required equipment to do the planning, if it is a point-to-point planning or point-to-multi-point plan. But it's based on filters. So when I check a platform, it will go to the bill of material that I choose, and later on I need to choose the file that I saved in order to create the catalog. So at the end, I have a one file catalog. It can be for point-to-point, it can be for point-to-multi-point, or a mixed point-to-multi-point and point-to-point solution. So afterwards, I type the credential. I can load previous planned project, create a new project, or import a plan, a PRJ file. This is the three options that I have when I just can load previous planned project, create a new plan, or import a PRJ file. So when I do a new plan, this is a new plan, I need to type the project name, the operator name, city, country, climate factor, of course, the frequency that I want to work with, the synchronization method, HSS, the hub site sync. It can be over Ethernet or through GPS synchronization. When I use synchronization over Ethernet and when I use synchronization over GSU, what is inter-synchronization, what is inter-synchronization? All this is part of course, RADWIN inter-synchronization, but the radio planning knows to do it for you and give you the recommendation how to do the synchronization. And we all know, we all understand that synchronization is very, very important to overcome interference, all kinds of interference, co-channel interference, RADWIN interference, inter or intra-interference. We need to synchronize. When I'm listening, I want nobody to transmit. When I'm transmitting, I'm the only one who needs to be transmitted together. All the subscribers or all the base stations on a one tower need to transmit simultaneously and receive simultaneously and not interfere each other. But this is the idea of synchronization. What is the TX ratio? What is the uplink downlink ratio? It depends on synchronization. What is the duty cycle of the transmitting? It's all need to be considered when we are doing the planning. And it is not less important than the frequency that we are choosing and the channel bandwidth. And remember, when we have a narrow channel bandwidth, we are less interfering, or we are less exposed to interference. When we have a wider channel bandwidth, we are more expected or exposed to interference. What is the climate? I'm looking at the climate. What is the climate factor for every region? What is humidity? What is the rainy season that need to be considered in order to create and to calculate the availability of the. So we create a new plan. After clicking the create new plan, the plan wizard dialog will show up. Whatever you set here will be used as the default setting for your plan. Every link and site you add will use this setting. You can always edit this setting as need arises for a specific customization. So select the catalog you have composed earlier via WinPro. Set the climate factor, service, and synchronization. Set the default required service. Click create a button to proceed. So I put the radio plan, the project name, the operator name, the city, the country, the climate factor, the frequency that I am going to use, default antenna height, and synchronization method. Climate factor. And we have exact map of difficult, good, average, moderate climate factor to be considered when we are creating the link. This will impact the availability, because availability takes into consideration the climate factor, and it calculates the outage probability of a link. And actually, when we are planning a link, I prefer that I will have 100% availability. But of course, it is physics, and we cannot get 100% availability. But there are some parameters that we take into consideration to calculate the probability of availability, like rainy season, equipment failure, like multipass. This is all taken into consideration when we are doing the availability. In the major of the carriers or the cellular companies or the wireless companies, 4 nines, it is the availability that need to be considered. 4 nines mean 99.99% availability. It means that we have we are more secured to protect a link from outage. And one of the parameters that need to be considered is the climate factor. To understand what is the probability to have an outage. Synchronization method for intra or inter-site. Here we need to take into consideration how we are going to synchronize the link. When we discussed about synchronization, in every tower or every pole, there must be one primary synchronization unit. This is what we call the master clock. When there is one master clock, the other will be the slave. If there is a GSU, GSU is the master. GSU is the master, and of course, he will provide the clock for all the other devices in the tower, under the tower. But there is also inter-synchronization between towers. It depends on the distance of the tower. And usually, when we have a point-to-multipoint deployment, we are going to enable the integrated GPS for each base station. So it becomes more easier. We need just to enable the GPS, and we are all synchronized to one source of clock, the satellite. When it is satellite clock, then first it's accurate clock, and it is the clock that exists. It's easy. When we have one source of clock, all the base stations are synchronized to the GPS clock, and we are synchronized. Synchronization over Ethernet is little bit more complicated because we need to provide the clock over the Ethernet, and we require a layer 2 switch that broadcasts the clock. The synchronization packet are layer 2 packets. Sometimes it is efficient to put and to define a VLAN for synchronization, specific VLAN to avoid broadcasting in your network, and in most cases, it will ask you to define, to configure a domain name for synchronization. Remember that there must be a master clock, and when we define a master clock, all the other devices will be slave. When we open the synchronization parameter on the RPlanner tool, you will see a master M, client C, and you will see independent. If a base station is the master and it provides the clock, then the subscriber becomes independent because it is inherent the clock from the base station. When I open the screen and you will see the synchronization, you will see the master, the client, and the independent. One device, one ODU must be the master. If it is a GSU, GSU becomes the master. If it is a point-to-multipoint and there is a jet duo or jet beamforming, the jet has integrated GPS, and the integrated GPS is the clock for all the deployment of point-to-multipoint. Of course, as I showed you before, there is a WinPro, and we need to create a catalog. The catalog for point-to-point, the catalog for point-to-multipoint, and when we are creating the plan, the RPlanner takes all the technical parameters to design the link and consider all the link budget calculator for each one of the devices to calculate the interference, to calculate the RSSI, to calculate the TX power and the modulation in accordance to each unique device. It can be the alpha point-to-point, it can be the jet beamforming, and so on. For example, jet beamforming is a 90 degree azimuth. It is a 20 dBi antenna gain. It transmits up to 25 dB for all modulation. And it all needs to be calculated when we are doing the planning. So we need to create the RADWIN catalog. The RADWIN catalog is based on the WinPro catalog, where you need to filter the devices that we need to that are required to do the planning. All we have to do now is to select and narrow down our option till the list shown what we look for. Again, we have all the families from left to right, the RADWIN 2000, the RADWIN 5000, and the JET subscriber unit. Our IDUs, PoE, antennas, cables, accessories, all what we need to do the planning. To do the planning and to do the later on the installation and deployment at the site. So the WinPro, when we are doing the catalog, we need to choose the right equipment which are required to do the planning. It depends on different regulation. It depends on channel bandwidth, and help us to do the planning. WinPro filters, we need to filter, and when we filter the right parameters, we can summarize the catalog or the equipment that are required. So I can decide that I use integrated antenna. The regulation is universal without ERP limitation. The default band is 5.4. the throughput that I want to achieve is 100 aggregated uplink and downlink, and I'm choosing the RADWIN 2000 or RADWIN 5000 platform. At the end, you will get a summary of those equipment, and on the left you have a checkbox to check only the detailed equipment that are required to do the point-to-point or point-to-multipoint plan. So when I save the catalog, I need to choose it again, and immediately when I choose the frequencies for point-to-point or point-to-multipoint, it will give me from the list of the catalog the equipment that was chosen in the catalog. Immediately it will show the information on the RPlanner screen. There is a button on the right. It's called include band, which required license key. So it gives you the flexibility to work with ETSI regulation, but on the same time to simulate what happened or what if I will ignore any EIRP limitation and I choose universal band. So, for example, if you're under the ETSI regulation and you work in Europe, you can choose the ETSI equipment, and on the same time, when you are doing the planning, you can calculate and do a link budget calculator without any EIRP limitation. This is what this is the button which called the include band, which requires license key. So you can choose ETSI devices because you're working in Europe, but at the same time you can simulate a non-EIRP limitation. So actually you can check your performance without any EIRP limitation. What is, of course, you will get better distance, you will get better modulation via distance because you are transmitting without any limitation. And this is the idea of this checkbox on the right. So once we did the catalog, you choose the catalog, and then you are continuing to immediately choose the equipment that requires for point-to-point and point-to-multipoint. And of course, you need to decide which channel bandwidth you are working with. And again, all these parameters can be configured again and changed according to the planning and simulation that you are doing. Now, you can add, when you are pressing on the second button on the top, you can add site, you can import site, you can export site. Your option is type past coordinates, find address, import site, import links. You can use the mouse current position on the screen or import build topology using RADWIN template. This is the option that you have in order to add site links to the planning. There is another technique. I will show you how to import KMZ file and to add sites to the planning, which you make your planning easy and flexible. Right-click where the site is needed to be installed, navigate through your new menu as shown below, click the site and add site right image. So actually, if I go to the planning that I did, this is the planning that I did. If I go again from left to right, you can see that I go to project setting. This is the planning that I did. It's a pilot for Senegal. The climate factor is 4 because it is moderate. This is because this is the average. I choose the climate factor, I choose the frequency, and I chose the GS0 as the main source of clocking for this plan. I press the next, and you can see that I created a catalog. The catalog is based on WinPro, on the WinPro catalog of RADWIN. And again, I did the filtering according to the requirement. And I chose this equipment. I chose point-to-point alpha. I choose SU HBS air. I choose SU air to do the planning. But again, it's based on the filter. Integrated, universal, 5.4, $250, and jet. And of course, I have one option. For the point-to-point, I choose integrated, universal, 5.4, and 50 megabit per second uplink and downlink. And this is the alpha that was choosing in the catalog. So in order to do the catalog, I have the RADWIN point to multi-point base station air and the alpha 50 megabit per second point to point. It's all based on universal band, 5.4, and different capacity or different output. Immediately when I choose the catalog, according to the catalog list that I have, I choose the frequency. I don't forget to check this box, and immediately I get the point-to-point equipment and the point-to-multipoint. I choose the channel bandwidth. Next, I need to define, again, let's go back to define the availability. And remember, I can plan my link on a 99, 999 or a 49. Usually, I will start to do the 49s, and in some cases, when I have 99.95, I choose 999. Again, it depends on your policy, how you want to protect your link and how you want to cope with deterioration of the signal in case of interference. This is the phase margin and the availability that you are going to do the planning with. When I finish the plan, I can start doing the planning. I created the catalog, I created the condition for the planning, and now I can add site. I can add site by coordinates. I can add site by import site, and I can do it with a CSV file, KMZ file, or KML. Let me show you something like this. What I'm going to do now is to create a KMZ file. I created the KMZ file. This is the KMZ file. I can import this KMZ file from here, add site or import site. If I want to import site, I can import KMZ file. I press on the file that I want to import, and immediately I get all the information about the site that are going to be imported. If I import selected, of course I have it twice, but look what happened. I have all the imported site again on the map. And now when I do the planning, I will decide where is the base station according to topological or a towers condition, or it depends on what is the central site, what is the remote site, and so on. For this plan, this site is going to be a base station site because it concentrates all the subscribers around. And of course, I can start to decide if it is a point-to-point or a point-to-multipoint. Here the limitation were the profile of the link. For example, this link is a very problematic one. I need 35 meters on the base station and 22 meters on the subscriber, and still I get less than 1% funnel zone. So I can add a site according to CSV file or KMZ file, or I can just edit with a coordinate, with latitude, longitude, and the height from the ground for the tower. This is the way how to import site to the plan. And then I can decide which is a point-to-point or which is a point-to-multipoint and start to create the plan. Of course, I can manipulate the site again. If you can see, I can choose all the area. I can delete the area and vanished. I can do again, come here, import site, KMZ file or CSV file, and immediately I imported the site again. I will decide that this will be the base station. I will decide which frequency. And remember, I can play with the frequency and simulate universal band or ETSI band according to the product in the catalog that I choose. I can do ETSI and then move to universal to see what is the difference between. I will decide the channel bandwidth, the name of the sector, and usually I will put direction. For example, this will be the north. I will decide which is the frequency, the product, which I choose from the catalog, the channel bandwidth, and RADWIN support dynamic channel bandwidth 20, 40, 80 dynamic. I will choose the frequency. I need to provide the sector ID, the subscriber unit from the catalog, and I can now start to define and design the point-to-point and the point-to-multipoint that I want to do. This is remember, this is the north sector. So I can decide which subscriber to cover. It can be like this. and I have the first sector on the north, facing the north. Remember, the dark areas are non-line of sight. As much as you are going far away from the base station, the modulation are getting lower and lower. So I expect dark red close to the base, and it would go and get less dark or less red towards the far subscriber. And then when we are doing the planning, we need to understand and consider the capability of each product subscriber unit or a point-to-point to provide the performance that we want to achieve according to the antenna gain, the fade margin, the TX power, the modulation, and so on. But the first thing that we need to check is line of sight. To create the profile. This is the first thing that I usually do to verify the near line of sight, the line of sight for each customer. For this pair, for example, this one, I can see that I can expect line of sight issues. So once we added the site, we can continue to do the planning and do the coverage for each site. Use the mark right click to manually adding the site where needed. So I can do it manually even by right click on and add a site. And again, I can check the profile of the link. I can see that I can get 0.9 Fresnel clearness with this link. I can add it to the base station by creating a point to multi-point link. Currently, I have only one base station. I create a link, but you can see that I have many red alarms. The red alarm indicates that there is a problem with the fade margin, with the RSS, and you can see the availability is 0. Now, why is that the availability is 0? And I'm asking you, and you can think about the answer. I have a link which is connected to a base station, but you can see that if I look at the properties indicates that the availability is 0. And remember, we are planning availability of 999 availability. But I can see the fade margin is -49 in both directions, and availability is 0. Of course, this is not acceptable link. Why is that? Because we are connected a link to a non-coverage area to the base station. So in order to activate this link, let's delete it. I will go here to look at the coverage, right click on the coverage. I will delete the coverage, and I will create again the coverage from the base station. Something like this. I put the red color, I put 13 kilometers, and add. You can see that there's the dark area here, I will check the profile again. 10 to 35. My opinion, we can expect a problem here. Let's put a set site. Check the profile here. And you can see there is a mountain. Even there is a tree here, we can expect a problem. So this area should be at least 20 meters. And now I can delete this one. And create a link. And you can see a link that is functions. It's red, it's a green, and we can get 50 megabit per second for uplink and downlink on each side. So I can import sites with a KMZ file, I can import with a CSV file, or I can do it manually by the coordinates of each site. Now, if it is a point-to-point, there is a button on the left to define this site as a subscriber site. You can define the height. You can define the site name. And define whether it is a point-to-point or point-to-multipoint. So actually, you can add the site by coordinates, by a CSV file, or KML or KMZ file. You can edit a file, you can decide which is the coordinate and give the height of the tower or of the antenna on the tower and import the site. You can import links with a CSV file according to the syntax of the file. And actually, once we did the importing of the site, we can start doing the planning point-to-point or point-to-point, multi-point, and to understand what is the need and the technical specification and performance that we get according to each planning. And remember, we started the course with a link budget calculator. And when I look at the link budget calculator, this is the fundamental of RADWIN planning, point-to-point or point-to-multipoint. And the R planner, the radio planning, is based on link budget calculator to determine the performance of the link when we are doing the designing of the link. Design of link is not only spectrum, is not only frequency. Design of the link is all the parameters that need to be considered when we are doing the link and when doing the planning. The coverage area, near line of sight, no line of sight, and again, the phase margin, the availability, the climate factor, the TX power, the modulation, the distance. At the end, the antenna gain. At the end, we need to achieve good performance and the maximum throughput. This is the idea of the RADWIN radio planning. It will give you all this information when you are doing the planning. And when I did the right click on the link, I get the performance of the link. And all these parameters will be part of the calculation that the RADWIN tool is doing for you. Tomorrow we will continue to do the planning for point-to-point and point-to-multipoint, and we'll see what is the difference between the requirement for point-to-point, point-to-multipoint, and what are the tricks that we can have to get a fast, quick auto planning. Some of the features that we have to enjoy a quick and fast planning. Thank you for your time, for listening, and I will see you tomorrow. Thank you for that, for providing answer, and I will see you tomorrow at the same time. Thank you for your time.